Hello friends, welcome back, and in this video we are going to see about the open close principle, the second principle in the solid OOPS principle series. So in the previous video we have seen the single responsibility principle, and now in this video we are going to see the open close principle. So let me tell you one thing, that in these videos I am just going to tell you theoretical portion of these principles. You need to understand these concepts very in concise manner, and when I will explain it with the help of the example in the coming videos. I will take some example of some code as well. In these videos I will take some small examples which can make you easily understand these concepts. But yeah, these are not the complete videos on these things. So this video is only a theoretical portion for the open close principle. So what is the open close principle? First of all, understand that this principle simply states that a module or a class should be open for extension but should be closed for modification. What does this mean? This means that if you have any class or any any function you have written, not function, let's come to the class only. If you have any class or any module which is a set of classes, it should be designed in such a way that it is open for the extension. Open for the extension means you can add new things. If there is a new requirement which is coming from the client, that requirement you can easily accommodate. It should not be like, you, if some new requirement comes, you think that no, if something new will come, I will not be able to accommodate. No, this should not be the case. If this is the case, then in that case your code is violating the open close principle and you need to correct the class design, right? So in case of open close principle, you need to take care of this thing, that if any new requirement is coming which you need to implement in your class, then in that case it should be easy for you to achieve that. First thing. Second thing, if you are implementing any new thing in your class as per the new requirement, I repeat again, if you are implementing any new thing as per the new requirement from the client in your class, then in that case, whatever existing code or existing functions are there in your class, they should not be forced to be modified. Which means that if you are adding something new, then it should not be the case that you are touching the existing code. You are adding there something which is shaking your code, right? Which is tampering your code to some extent, because in that case it will open the scope of unit testing of those things which are not in the scope, because new requirement is only the new requirement which should be tested. But if you are accommodating new requirement, and to accommodate this new requirement, to implement this new requirement, if you have to touch the existing code, then what does it mean? If you touch the existing code, then it means that you have to write the test cases, unit test cases, for testing those changes as well, which were not at all in the scope because of this new requirement, right? So this is a wrong design. If your class is violating this principle, whatever has been said, if your class is working something like, if you add something new, you have to touch the existing code, you have to change the existing code, then in that case it is simply violating the open close principle, and you should not follow that, and you should redesign that class. That is the main purpose of open close principle. So this is the another principle which you need to take care of, which you need to keep in your mind while you're designing your classes, so that you write the good code, manageable code, maintainable code. Otherwise you will be ending up writing such a code which is not maintainable at all and will create different kind of problems, right? So these kind of things are usually discussed in the interviews as well, and by the when the design is done by the technical architects, by the low level designers, then in that case these things are discussed. And if you get some piece of code which you need to refactor, and if you see something like this, complain, create a request, create a ticket that yes, this is a problem in your code, you need to redesign it, this is not the right code. And if you are a reviewer, you are a code reviewer, if you are a senior developer who reviews the code of your subordinates, then in that case, if you have this kind of thing in your mind, you can write a comment that yes, this is not the right way to write the code. In case in future something new requirement will come, in that case, will it follow the open close principle? If the answer is no, just put a comment, and that comment need to be resolved, that piece of code need to be resolved by your subordinate, right? So these things you need to take care of, right? So this is the open close principle, and I hope you might be getting some idea what we are trying to say here, what we are trying to achieve by following the open close principle, right? So this principle is related to the OOPS concepts. We are here with respect to the OOPS concepts, right? Object oriented principles and object oriented concepts make it easy, right, to understand these things. But without the oops concepts, without the implementation of oops concept, when there was only C language, when there was no such language which is known as the object oriented language, because C++ was the object oriented language, then Java came, then C# came. These are all the object oriented languages. But in absence of these object oriented languages, was there any possibility that these principles were getting followed? The answer is yes, right? Let me tell you one example, right? It was done in some other way, but yeah, this was getting followed, right? This principle was getting followed, that a module, a class should be open for extension, but it should be closed for modification. Let me tell you one interesting thing, and this should increase your knowledge as well with respect to the computers. So let me tell you one example where without the oops concept, this open close principle was being followed, and the example is the device drivers, right? So let me tell you one thing before device drivers. Since we are talking about the device drivers, let me tell you one more thing, that how the device drivers they work, and how things are implemented in the code, by the system programming, right? So when your computer starts, listen carefully, when your computer starts, in that case there is the first module which gets started, initiated, is the bootstrap loader. Bootstrap loader, right? It loads the boot program, right? After this, it checks all the peripherals, your keyboard, your mouse, every other device which is connected to your computer, whether it is functioning properly or not, whether it is proper or not, whether there is connection or not. So all the peripherals, they are tested, they are checked, right? That is known as power on self test post, right? That is done. And after that, when all the things are getting initiated, after that, one thread is initiated. That thread is system. This is a system thread. That thread is known as raw input thread. That thread is known as raw input thread. This thread is initially in the suspended state, which means it is not working. It is there only. It is not scheduled. It is not working. It is not in the working state. It is scheduled only. It is in the suspended. It is in the suspended state, not in the scheduled state, right? It is only there, right? It is in the suspended state. This thread is reading inputs from a queue. This queue is known as SHI System Hardware Interrupt Queue. This System Hardware Interrupt Queue has number of entries. And what are those entries? Initially, there are no entries. As soon as your computer comes up, after that, what happens, that there is a keyboard, there is a mouse, there is another device, the D1, something like that. So these devices put the entries here one by one in the queue. And as soon as one entry comes here, this thread becomes scheduled. This becomes active. This thread becomes active and start reading from this queue. And as soon as it starts reading from that queue, this start taking the actions, which means, suppose if you have clicked something through the mouse, then the device driver of the mouse, between the mouse and this software system hardware interrupt queue, there is a device driver. The device driver is a program which is sitting between the mouse and the, or you can say the device and the system hardware interrupt queue. So this device driver which is sitting between the device and the queue, this program, it takes the input from this and convert that input into a message, and that message is placed into the SHIQ. I repeat again, this mouse or any device first puts it entry, first it interacts with the device driver, and that device driver converts the message coming from the device into a computer readable format, and that format has a specific number, as a specific integer. For example, if you press enter, then it's it has a key value which is 13, right? So 13 means someone has pressed enter. So this enter or 13, this is placed into the queue, right? So this mouse and this device driver and this queue, they work together. So when your mouse is clicked, then in that case, first it connects with the device driver program of the mouse, and this device driver program of the mouse, this converts that message into a integer value, and it is placed into the system hardware interrupt queue. As soon as this is placed into the system hardware interrupt queue, this thread gets scheduled, and then it reads that what message has come, and whatever message has come, this message is processed by the system and the action is taken. Like if you have clicked on some if you have clicked on some folder, then in that, if you have double clicked on some folder or clicked on folder, accordingly whatever action need to be taken by that click, that is done that is processed by the computer system, and that action you can see has been taken, right? So everything is a thread in window, everything is a thread. So this thread read the message and pass the message to that window for which this mouse was sending the message and for which this message was intended. For example, if you have opened some particular window and you are pressing some key from the pressing mouse button, then in that case that particular window need that message. So this thread takes this message and whatever active window is there, because active window is the main window on which you are working, so this takes the message from here and it puts into here. So this is the way this particular window gets the message and you handle that message. You get the message. If you write a program, you get the message in the form of event. You have written the delegates and events in C# code. If you are aware about the delegates and events, then you might be understanding what I'm saying. So you get this message here, right, in the other window, and then you see, then you think that yes, mouse has directly sent it to me. No, mouse doesn't directly send it to you. It goes through this process. This entire process is behind the scene before it reaches to your window. So this is how it works. So when you talk about the device driver, this device driver is for the mouse. Similarly, there is a device driver for the keyboard. So these two device drivers are by default installed, right? They are installed and they work properly. But in future, someone says that I have to add an scanner, right? Add a MCR, OCR scanner, or the IIC, some other magnetic MICR character reader, something like that. I want to add that particular device as well. So for that as well, you have to write a device driver program, and that device driver program need to be installed here, right? So when you install these device driver programs, in that case, there is nothing needed to touch to any of the existing drivers. It is not like if you are installing any new driver, like if you are installing a driver for the scanner, then in that case you need to touch any of the driver, or you need to again reinstall some other driver. No, you don't need to reinstall any other driver. You just need to install your own driver, new driver. So it means that your device drivers program, or you say like whatever this layer is where the device driver is placed, these device drivers can be independently installed, which means that they are open for extension. I mean, you can extend any number of device drivers without touching any existing device driver. So this is the example of open close principle without the presence of object oriented concepts, object oriented programming language. So this is always maintained. These are not object oriented specific concepts. These are the basic principles of programming. Whether you write any program using the classes, or whether you write any program without classes, or any program in C language, you need to take care of these concepts. It is not like these concepts are introduced for the object-oriented programming language. No, not at all. Don't confuse with this one. These are not written for object-oriented programming language. These are told with respect to the object-oriented programming language, because you need to know that how these concepts can be implemented using the object oriented concepts. So that is the thing. This is the example which you have seen, and I also did this thing because I wanted you to know as well, because most of the people don't know that how the messages reach to the window, how it reaches to the window, what is the raw input thread, what is system hardware interrupt queue when it gets initiated. It gets initiated after all the things are initialized in your computer system. After this, it gets initiated. Right? So you might have understood now that these are concepts. Why I told this example? Because I wanted to tell you that these principles are not written for the object-oriented programming languages, but these principles are told to maintain any kind of code. To write any kind of code, you need to take care of this thing. Even if you're writing a function, you need to take care that yes, any new thing which will be added is not going to touch anything else which has already been written. Right? So with this principle, if you follow this principle, then your code will be clean. Then when you will write the unit test cases for the new changes that you have done, you don't have to do much effort to write extra test cases. Rather, you can only test the new piece of code that you have written. So if you are not able to do this with your code, then it means that your code is not following the open close principle. That is it. Now let me give you an example. Suppose there is some example. Suppose I'm just going to take one example. Suppose I want to write something to the something to the file. I created a class. Suppose I created a class, and I given the name as print2. right? And in this print2, I have written one function. In this print2, I have written one function which will print some content. In this function is taking some content as an input, and I'm writing this, I'm writing this thing to some file, right? On some hard disk file. So file dot write. I'm writing something. This content I'm writing using the hard disk file, opening the hard disk file. Now what will happen? You just written like file dot write. In future, something came. Customer says that I not only want to write it into the in the hard disk file, but also I want to write it into the printer content as well. I want to send it to the printer as well. So what you will do, if you have written this class and if you have this function, what you will do, you will take one more parameter and you will write some code like this. If target is equal to hard disk file hdf, then write one, means write to the hard disk, and if else if target is equal to your printer, then send to printer. You will write to printer. Second thing. Third thing, if someone says that whatever you have written you have to save to the database as well, then what you will do, else if target is equal to db, then you will send it to db, right? So you can see that you are adding new request. You are adding the request in this else if. You have added it in this else if, but what is happening? The thing which is happening is that in this function you have to touch existing code, right? You have to, this is the function which was existing, and this existing function has to be modified. And since you are modifying this existing code, you, as a rule, you have to write new test cases to test all these things, which increases your effort for unit testing. And this is what is not good coding practice, right? It's not a good programming practice. So that is why you need to take care of this, that you don't follow this practice which forces you to touch the existing code which was already there, right? So if you are doing this, if you are forced to do this, then it means that your code is not following the open close principle, and you need to take care of this. So this was the example of violation of the open close principle. If some code you have written like this, then it means that you are violating the open close principle. But I believe most of you must be writing this kind of code only, right? The solution is, if you want to make it follow the open close principle, the solution is that you write one abstract class, the top level class. You can write a class base print, or base write, or you can write base write. This is the base write program. In this base write program, you can create two functions which will be overridden in the other classes. You can write a function void write. Okay, you just write this function which will be overridden in the other derived classes. So what you can do now, first request comes. That request is that you need to write the content to the file. So what you will do, you will write a class write to file, right? And you will inherit. You will inherit it from the class page write, base write, right? So you will write like class write to file extends base write, right? So now you will extend the base write and you will override void write. So in this particular class, in this function void write, the name of the function will be same. You don't need to write any other name. Name of the function will be same. You are just overriding that function in this particular write to file class. And here you are writing to the hard disk file. Here you will write in the hard disk file. So when you will test, you need to only test this class. You don't need to test any other class, right? You will just create object like base write. You will create the object like this. Base write bw is equal to new write to file, right? You will write something like this. When you will write something like this, now this bw, when this bw will call this function write, then what write it will call? It will call this write, right? So basically when you are writing any of the function in such a manner so that your main class, the top level class, acts as an interface, then in that case you are maintaining your code in such a way that it will follow the open close principle. So your first class, the base class, should act as an interface. In this main interface there should be a method, but that method should not be directly called. That method should be called as per the requirement, as per the request at runtime. Suppose someone is trying to write to the hard disk file, then in that case this particular object should be created. This base write is equal to write to file, and this bw.write, this should be called. When you will call this dot write, it will call this function, the write. Now someone says that you have to write one more, you have to write one more class, or customer requirement comes that I also want to save it to the database. So what you will do, you will write another class save db extends base write. Right, so here what you will do, you will again override void that function. What was the name? Write. You will write the code which will save in the database. Now if you have to test this code, you will simply create one object, base w bw is the base write is equal to base write bw is equal to new save db, and now when you will call this write, then this write will be called for the db. I mean, with whatever class object you will create, whatever instance you will create, only the write function or only the save function, whatever you have I have written the write function, so that write function for that particular class will be called. Now let me know, you can understand easily that if you have to test this class, do you need to touch this code? You have not touched this code, you have not written any if else, you just written a new class and you can simply test this class. There is no scope of extending any unit test cases to the existing code, right? So this is the good coding practice. This makes your code more maintainable, more feasible to maintain in the future, right? So this is how you can maintain your code in the open close principle, following the open close principle. Another one you can do like class print it extends, you can give the name base write, right? So here you can write some code which can send the content to the printer. So this is the way you can extend your existing code, existing module, without touching the existing code, right? So there is extension which is happening, but there is no modification to the existing code. So we are following in this example the principle of open close, right? So this open close principle makes your code more readable, more easier to maintain, right? So these are the things which you need to take care of, and this is the example which I wanted to share with you. And in the coming videos, when I will take the example of code, we will take some real example. Here I have just done a classroom exercise for you, but in the coming video I will do a few more things in the real example, right? So with this particular video comes to an end. We'll meet soon in the next video. Till then, have a nice day and bye bye.